Hey everyone! Today we have another BIOS programming video for you. Specifically, we're going to make a boot sector game, and that game is going to be a Pong clone. So hopefully you find this enjoyable, and this will definitely be a little bit of a longer video, but let's get into it. So the first thing we're going to do is we are going to set up our display to be display mode 3. And if you're wondering why we chose that, it's so that we can show colored text on the screen. And I do have another video explaining about setting up the display and why we're doing it. And that's the other neat thing about this video, is it's going to be kind of a culmination of all the things that we've talked about previously. We also will be working with colored text. So what we will do is we are going to use memory directly. And to do that, we will be saving the B800 memory address on the stack and then popping it into ES. And then after that, let's just test to make sure this is working. So let's put a white ball on the screen. And to do that, we are using 77, which is, let me pull it up here. If we go to this little website that I have, you can see that setting up the display, it talks about all that here. And then with the colored text, you can see the memory addresses being here. We're using moves here instead of push and pop, but same idea. And then we want, we're going to show a little white cursor basically here, or a space. So we're going to use 77, 7 being the background color of 7 and the foreground color of 7. So let's do that. And, oh, already did that, okay. And then 20 is, if you go under the ASCII table and look for space, the space is hexadecimal 20. So what we have done here is we've set our video mode to 3, which is colored text. We're going to access the memory directly, and then 77 means white background or light gray and foreground, and then 20 is our character. And we do need to set DI, which is the destination index. So we will set that to 0, and then we will do a store string word because we need to pass both color information and character. And then we also want to clear interrupts and halt. If you don't do this, sometimes your program will just, well, it will just keep on running and running and running, and eventually it will hit things that it shouldn't hit. Now you'll notice that I have biosignature here instead of the AA55, and that's a handy little reminder that we want to use constants to help explain what our code is doing. Now, when I build this, hopefully it will work. And let's run it. And we do have a character up in the top corner here. If we look at the binary file, you can see that AA55 is nowhere up here. It's only here. And what that's basically illustrating for us is that AA55 is going into the assembler, not into our binary. So this is not taking up any extra space, and it's a lot more descriptive than just the magic number AA55. If you're wondering why we even need that at all, again, on the website, it explains the getting started here, or you can watch the video, whichever you prefer. All right, so how about if we draw that separator, the line that goes down the center of the screen? Well, let's switch over to the color blue. So that should be number 1. So we will set this to 1120. And instead of doing it at 0, we're going to need to go over 40 characters because there is 80 characters in a row, or 80 columns in a row. So let's start doing a little bit of math. Let's start saving this display address because we want to document as we go along here. And we'll call this blue space because that's what it is. Now, we said we wanted to go over 40, but the reason for that is columns in a row equal 80, and we want half of that, but we also need the number of bytes in a word, which happens to be 2, because remember, we're moving words around, not just bytes. So what we're going to do here is we're going to do columns in a row divided by 2, because we want to go only halfway, but then we need to multiply it by the number of bytes in a word. And this should give us a blue square pretty much in the middle of the screen. It won't be perfect, but it helps to actually type in make first. And you can see it's off by 1. And the reason for that is this is 0-based indexing, not 1-based indexing. So we need to subtract basically a word. All right. One other thing that you might be wondering about is this is what my make file currently is. If you're not using Linux and you are using Windows, instead of using make like I am, you could actually type in these commands, or you could make a little batch file. That would be the equivalent thing to do. I have a video that explains why I do this and how it allows us to debug by stepping through our code. And actually, where we're at here, I'm going to just open up the binary file. This is our current output, but let's actually step through this. So I'm going to drop a breakpoint here, make debug, and then run the debugger. Now, if we pull this, we're going to need to do side by side. All right, there we go. So you can see we're moving that blue space into AX, and we're setting our DI, but nothing will actually happen until we run store string word. And ta-da, there it is. So this actually stores AX with all the blue space information at wherever DI happens to be. And it's not just DI, it's actually ES DI. So that's fairly helpful. And this isn't complicated yet, but that is how we're going to be debugging this. Now I noticed that we don't have any watches yet, so let's add those while we're here. So we're going to add our AX register. We're going to add our BX register. Oops. Try that again. BX. And we'll do CX along with DX. I'm going to throw a tilde in there, which does nothing, but it gives me basically a little divider. And we're going to need to know where our code segment is, our data segment, our extra segment, which is B800. So we know that this is working as well. And we might as well throw in our stack segment. That should do all of our segments. Now let's do our string source index, destination index first. We'll try to go alphabetical. And our source index. We don't really need variables because we're never going to really have any. And all right, so we can also put in here a base pointer. We won't work with that a whole lot. We'll throw in the stack pointer. That might be helpful someday. And we'll also put in a program counter, which is just which line of code we're on. So we start at 7C00, and we are at the 10th location here. All right, well, that's all working now. We're all set up so that we can do debugging in the future, so that is helpful. So we have a blue space, but now what we want to do is actually go every other line all the way down. So let's just do a dry run real quick, and let's do, we're going to store our string word here, and then let's add to DI, it would be columns in a row times 2 times the number of bytes in a word, and I think we're going to have to subtract that 1 off again because store string word will automatically basically move the cursor over by 1. So we did all that. Now let's store it again. And let's see what happens. We have 2 of them. All right, well, I would say that we're ready to start looping. So we're going to want to run this a total of 13 times because there's going to be 25 rows here. So what we're going to do is we will store, let's create a separator loop, and we're going to loop our separator loop, but we have to set CX for the loop command to work. So we're going to set our CX to 13, and let's make it and run it. There's our little divider. Now, if we didn't have our clear interrupts and halt, the program would keep running and you might get some funny characters here and who knows whatever else. So that's why we did what we did. All right, so we got our blue separator. Let's add in a paddle over here because it's Pong after all. So let's put in the user's paddle. We'll just start at address 0 and then we will build up from there. So let's do move into AX. This time we're going to do a white space, and this will be the same as we had before, the 7720. Might as well name that, right? White space. All right. Now for our DI, we're going to move 0 into our DI. We're going to just start at the very top. And let's store a string word. And let's run that real quick. Yep, there's the beginning of our paddle. So let's specify a paddle height to 5. So what we're going to do now is let's do a dry run first and make sure that our math makes sense. So we're going to take the number of columns in a row, multiply that by bytes in a word, and subtract off that extra one that comes along for free. And our paddle is growing. Very good. So we're going to do like we did before, and we're going to add in a paddle loop. We're going to loop our paddle loop. And we have to set CX again because it's a loop. So what we'll do is we're going to move into CX our paddle height. And the reason it's CX is your counter register. It's used for counting. So it's going to basically subtract 1 off of CX automatically each time it runs this. That should give us a paddle that is 5 high. And it does. Well, I'd say we're off to a pretty good start here. So the next thing we're going to want to do is let's accept a key press. And we'll do one that actually waits for us to start out. So that's going to be moving into AX. That is the 0 function if I recall correctly. And we can double check off of the website here for getting keys. It is 0, and we're going to be calling int16h. Okay. Yes. So we'll call int16h, and then what we need to do is we need to do a comparison, and we're going to compare AH, and we need to find out what the down arrow is. So if we look at our key codes table, down arrow is 50. 50 will be stored in the AH, and these are hexadecimals. So we'll compare AH to 50. And if it is indeed 50, what we'll do is jump equals, or we'll do jump not equals first. We're going to skip over it basically, and we will just call this halt. So if it doesn't equal, we're going to halt. If it does equal, we don't need to specify a jump. It'll just overflow into this next one, and what we'll do is we will say that, well, we need a variable, don't we? We want to move the paddle down. Right now the paddle's hard set to 0, 0. We can't necessarily use a constant because this is a variable. So let's call this paddle y. And it will be, we'll see if we can get by with a byte. Should be able to. Maybe not, because we're going to, let's just use a word. I think that's going to be cleaner in the long run. All right, so what we're going to do here is paddle y starts out as 0. Now we need to actually get the value of paddle y, so we're going to use the little square brackets. Paddle y, however, it is going to be multiplied by the number of columns in a row multiplied by the number of bytes in a word. And I think that'll give us what we want. So if it's 0, that's all 0. That's perfect. That's what we had before. Now let's say we change this to 1. 1 times 80 times 2 is 160. And I think that'll get us to the spot we need to be. So I guess the easiest way to check is to add this. And what we're going to do is let's move into, we'll do AX, I guess. We're going to move paddle into that, or paddle Y, I should say. We're going to increment AX, and then we're going to move paddle AX back into paddle Y. Well, I would say we probably need to run this again because we need a game loop of sorts. So we'll call it game loop, and we're going to jump to the game loop. Now this is a while loop rather than a for loop. So let's be a little bit explicit about what we're doing here. So this is a for loop, and this is not, I don't think, standard naming by any means. So if you're like, I've never seen anybody name stuff this way, that is just me. But it helps me keep track of what these labels are for. All right, so let's get back on track here. We have our loops named, and now what we need to do is we need to look at this right here. So currently this was originally 0 and we're bringing in 0, but when it increments it, what that's going to do is it'll move our paddle over to the left hand side of the screen, which is not really, or towards the right, from the left towards the right. There we go. That's not exactly what we want to do. So what we're going to do is just change this a little bit, and we're going to use the multiply instruction. So the multiply instruction works off of AX, so we set our paddle to AX, and then we're going to move into BX the, we can do it this way, number of columns in a row times number of bytes in a word. So what that should do is that should be the same once we call the multiply function. That should basically take the number of columns in a row times bytes in a word, so that's 160. It will take 160 times whatever's in here. So when it's 0, it'll still be 0. When it's 1, it should be 160. And when it's 2, it should be 320, I believe. But let's test it out and actually see what happens. Before we do that, though, we do need to store the value back into DI. So let's move bx into di. Let's see if this works. Well, it definitely moved it down. If we hit the down arrow, it did move it down. So, I mean, I guess that's a good thing. It's not working quite the way I wanted it to. So let's see what actually happened here. Let's do our little debugger to see what happens. So let's do a make again, and we'll do a make debug. And let's debug it. So when we did this, AX is 0, 0. So that's good. Next, let's go down, and we can see that BX is A0. And when we did our multiplication, what we ended up with is 0, 0 here. This needs to be AX, not BX. Okay. Let's try that again. And now if we hit the down arrow, it did move down. It didn't clear the screen, so that was the issue we had there. So let's add a screen clearer at the top here. So this should be pretty straightforward. Let's move into CX. We'll do AX first. And what we're gonna do here is we'll do 0, 20. So again, when we look at our colors here, 0 is black, and 20 again is the space. So what we will do is, let's call this black space. And once we've done that, now we can call this black space. If you hear noise in the background turning on and off, that's a fan. It is summertime currently, and it is hot. I wish I had air conditioning available for other than blowing a fan, but I am trying to close the door and keep the fan noise away. So if you hear sound and then it goes away, that's a fan. So please just disregard the noise in the background. All right, so now what we're going to do is we're going to move into DI, our 0 again, and in the CX, we need to do the total size of the screen. So that's going to be we have number of columns in a row. Let's do rows, and there's 25 rows. So now what we can do is we can do columns in a row multiplied by our rows. And since all these are constant static numbers, the assembler can do the math this way. We don't have to multiply it like we did here because this number is not a constant. That's why we had to do it. It's a variable. And since it's coming out of memory, it can't, during compile time or assemble time, do the math for us. That's why that happened, in case you were wondering. And let's just call this clear screen loop. And since we're naming things now, we will say that this is a for loop. We're going to do a store string word here. And then we're going to call loop and do the clear screen loop. So this should clear our screen, draw the separator, draw our paddle, wait for us to press the down arrow, run this again, and it should work. So let's see what happens. If we hit the down arrow, yep, that works. All right, so we're able to move our paddle down, and can we keep doing it? Yes, we can. So we can keep going down, but we can't come back up again. So we need to figure out how to deal and address that. So what we have here is if it's 50, and let's name that as well. down arrow. And we're also going to be cleaning this up as well. We're not going to just have one long thing of code here. Eventually we will start to include files, but I think when you don't have a whole lot of code, it's still easier when you can see it all on one screen like this. All right, so next what we're going to do is we are going to add up arrow. So we're going to change the way this works a little bit. Now what we're going to do is, if it is the, if it's the up arrow, which doesn't exist yet, let's add that. That is 48 in hex. Okay. So if it's up arrow, we want to jump to our we'll say up arrow branch. And we need if it's not up arrow, well, let's include that branch somewhere here. So up arrow branch. I'm going to call this a branch because that's what it is. And it is being used by our game loop, technically. Up arrow branch is basically going to do the exact same thing as this. And then after that, it will, we kind of almost need like an end logic here. So end get key and then we'll want to jump to that end get key. Otherwise, we should have our, if that is, so it's going to go to our up arrow branch here. Now what we want to do is, if that's not the case, we want to test and see if it is the down arrow. And if it is not the down arrow, then what we want to do is jump to our end get key. Otherwise, it will automatically run this logic for us. This is the fun part of assembly, figuring out how all these crazy branches work, but we'll step through it in a second and make sure everything looks right. I'm going to name it, even though we don't really need it. We'll call this down arrow branch. And again, it's a branch. It's being used by the game loop, but I'm going to put that as an overflow. That's how it gets to it. So, all right. So wait for our key press. Get our key press. If it's up arrow, go down here, and it will run through here, and it will continue on like nothing happened. Perfect. If it's not, it will overflow to this, and then it will check if it's a down arrow. If it is not the down arrow, it will go here and run the loop again and keep running. If it is the down arrow, it will run this logic, and then when it's done, it will jump down there. Easy, right? All right, and then instead of increment, this needs to de-increment, decrement, something like that. Ooh, something first use for the symbol jump. Yes. Okay, there we go. So if we hit the down arrow, down arrow, down arrow, down arrow, up arrow, up arrow, yep. we have a paddle that can move on the screen, but there still are no bounds. So it can go beyond where it should. So we should address that next. Well, unfortunately, I was not able to do all of this programming in one sitting. So I am going to be breaking it apart into multiple videos, unfortunately. However, I do plan on combining them all into, I guess it's called like a supercut. I don't know. I've seen that on YouTube before, where you have multiple parts and then you combine them all together into the masterpiece that you are working on creating. So I hope to see you in the next video or the next part. And I will just unfortunately have to continue working on this project. I was hoping to get it all done in one go. But anyway, we look forward to seeing you next time.